94% of people who start a machine learning course never finish it. 94. That's not a motivation problem. That's a curriculum problem. They're being taught the wrong things, in the wrong order, with math that doesn't matter yet, and they quit before they ever build anything real. In the next 10 minutes, that changes for you. You're going to understand exactly how machine learning actually works, not the textbook version, the real version. You'll know the difference between the three types of ML and when each one gets used in the real world. You'll see how a model actually learns, step by step, using a specific example you can picture in your head. And you'll walk away knowing which tools to use and how to write your first working ML code even if you've never done it before. And at the end, I'll reveal the single concept that separates people who actually ship ML projects from people who just watch tutorials forever. Most people never hear this. Stick around. So let's start with what machine learning actually is, because the definition you've probably heard is almost useless. Machines learning from data. Great. What does that mean on a Tuesday afternoon when you're trying to build something? Here's the real definition. Machine learning is when you write a program that improves its own rules based on examples, instead of you writing the rules yourself. That's it. That's the whole idea. Think about spam filters. The old way, a developer sits down and writes, if the email contains the word Nigerian prince, mark it as spam. But spammers adapt. So developers write more rules. Then more. It becomes a nightmare. The ML way, you feed the system thousands of emails already labeled spam or not spam, and it figures out the rules itself. It might discover patterns you'd never think to write. The combination of certain sending times, certain link structures, certain word frequencies. It finds the signal in the noise automatically. That's the core idea. You provide examples with known answers. The model finds patterns. Then it applies those patterns to new, unseen data. Simple. Powerful. Now let's break down the three types, because they're genuinely different animals. Type 1 is supervised learning. This is the most common type by a huge margin. Roughly 70% of real-world ML applications use it. You give the model labeled data. Input goes in, correct answer is attached. The model learns the relationship between the two. Predicting house prices based on square footage and location? Supervised. Classifying whether a tumor is malignant or benign from an MRI scan? Supervised. You're the supervisor, you're providing the correct answers during training. Type 2 is unsupervised learning. Here, you give the model data with no labels. No correct answers. You're saying, here's a pile of information, find the structure. This is what Netflix uses to group users into viewer segments without anyone manually labeling those groups. It's what cybersecurity systems use to detect unusual network behavior, not because someone defined what unusual looks like, but because the model found the natural clusters and spotted what fell outside them. Type 3 is reinforcement learning. This one's different. There's no dataset. Instead, you have an agent that takes actions in an environment, gets rewarded for good actions, penalized for bad ones, and gradually learns a strategy. This is how DeepMind's AlphaGo defeated the world champion at Go in 2016, a game with more possible positions than atoms in the observable universe. Nobody programmed it to play. It played millions of games against itself, chasing the reward signal. But here's where it gets interesting, because knowing the types doesn't help you until you understand how a model actually learns. And that process comes down to three things: a hypothesis, a loss function, and an optimizer. Let me make that concrete. Let's say you want to predict someone's salary based on their years of experience. Your hypothesis is the model's current best guess, maybe a simple line on a graph. You feed it some training data, 5 years experience, salary of $62,000. The model predicts $80,000. That's wrong. The loss function measures how wrong, in this case, the error is $18,000. Now the optimizer, most commonly a technique called gradient descent, adjusts the model's internal parameters slightly to reduce that error. Then it does it again. And again. Potentially millions of times. Each iteration, the line gets a little better. the errors get a little smaller. This loop, predict, measure error, adjust, is called training. And the thing that's doing the adjusting, the brain of the operation, is a set of numbers called weights and biases. When someone says a neural network learned something, what they mean is, those numbers got tuned through millions of iterations until the predictions became accurate enough to be useful. Quick note, if you're finding this useful, subscribing takes literally 2 seconds and it genuinely helps me keep making these for free. Now, back to how you actually build one of these things. Because here's the thing, you don't have to implement gradient descent yourself. Nobody does anymore. You use libraries. And the two you need to know right now are scikit-learn and TensorFlow. Scikit-learn is your starting point. It's a Python library, free, open source, and it lets you train a real ML model in about 10 lines of code. I mean that literally. Here's what it looks like for that salary prediction problem. You import linear regression from sklearn. You load your data. You call model.fit with your training data. Then you call model.predict with new input. That's it. Scikit-learn handles all the mathematics underneath. It's used in production systems at companies like Spotify and Booking.com. It's not a toy. TensorFlow, made by Google, is what you graduate to when you need neural networks, deeper models for image recognition, language processing, recommendation systems. It's more complex, but its high-level interface called Keras makes building a neural network almost as readable as plain English. You literally write, model.add, dense layer, 64 neurons. Add another layer. Compile. Fit. The abstraction is remarkable. Did you know the model behind Gmail's Smart Reply feature, those suggested responses like sounds good, or I'll take a look, was built using TensorFlow and processes over 1 billion replies per day? 1 billion. Daily. This isn't experimental technology. It's infrastructure. Now. The reveal I promised you at the start. The thing that separates people who actually finish and ship ML projects from people who stay stuck in tutorial loops forever. It's this: most people think the hard part of machine learning is the algorithm. It's not. According to a Google study published in their research blog, machine learning engineers spend up to 80% of their time not on modeling but on data preparation. Cleaning data. Handling missing values. Removing duplicates. Encoding categories into numbers. Normalizing scales so that a feature measured in dollars doesn't dominate a feature measured in years. The algorithm is maybe 20% of the work. The data pipeline is 80%. So if you want to actually build things, your first skill to develop isn't picking the fanciest model, it's getting good at Pandas, Python's data manipulation library. Learn how to clean a messy CSV. Learn how to spot and handle outliers. That skill will unlock everything else faster than any algorithm tutorial ever will. So here's exactly what you do today, not someday, today. 1. Install Python and open a free Google Colab notebook, no setup required, runs in your browser. 2. Load the Iris dataset using sklearn.datasets.load_iris, it's built in, no download needed. It's a classic classification problem with 150 labeled flower samples. Perfect for starting. 3. Train a decision tree classifier on it using scikit-learn. 5 lines of code. See what accuracy you get. Then open a Kaggle dataset. Kaggle.com has thousands of free, real-world datasets. Pick one that interests you, and practice cleaning it with pandas before you even think about running a model. 5. If you want to go deeper on neural networks, the Fast.ai free course is the most practical deep learning curriculum available online right now. Not my opinion, it's the course that produced some of the top performers in global ML competitions. You now know more about how machine learning actually works than most people who've been learning AI for months. You know the 3 types, you know the training loop, you know the tools, and you know where to focus your energy first. If this video saved you time or taught you something real, subscribe. I post every single week, and the next video is a hands-on walkthrough where I build a real predictive model from a messy Kaggle dataset, start to finish, no skipping the ugly parts. And tell me in the comments, which of the 3 types of machine learning are you most interested in building with: supervised, unsupervised, or reinforcement learning? I read every single reply.